Yes, Bismillahirrahmanirrahim. Today, last time we discussed about what is a VPC, how we can create our own VPC, what is the difference between default VPC and custom VPC. Then we also discussed about uh, how we can create our own VPC and what are the main element required in order to create the VPC, plus how it can communicate, how we can access our VPC. So today we will go more in depth, and we just 20 minutes we will go for the theory sessions, and then rest of the time we will go for the practical. In our practical, in today practical, we try to create our own VPC and launch the web server in a VPC. Okay. So this is our today lab. We will do it in today class. Okay. Now, before going to discuss our VPC, as we discussed in our previous lecture as well, first we need to understand the networking basic, which is just a revision. Okay. It's module 5. They just try to revise some networking concept which you already studied in computer network fundamental course. I hope you still you can just remind these concepts. Okay, so just we are going to recap those concepts today. Okay, so if you have any question, please you can ask. Okay, but the thing is we already studied. It is just a recap of networking basic. Okay, as you know, the computer network, everyone of you, because you already finished network fundamental. So the computer network is two or more client machines. See here, if these two client machines are interconnected with each other, okay, so we called, and we share the resources. So we called a computer network. So a network can be logically. So here, if you can see here, so these network, these computers are in subnet 1 and other computers are in subnet 2. You can see here. So these are the different. So in between there is a router. So the router, let me draw here. So the router, what is there in the router? So router will create, so we will create the routing table. It will connect this subnet and this subnet. So who will create the two different subnets? So we are connecting two different subnet with the help of routers. Okay. So this is the basic network. And so how the computers are connected here? With the help of the switch. Okay, so you need a switch here. So we are connecting all our computer in a with the help of the switch and two different network. This is again your switch. So you need to connect all the computers. Then in between there is a router. Okay, so this is a basic network. You already learned about it. Okay, now so you need to also know about the subnetting part. Okay, especially if you will see here the IP address. Okay, so now we will discuss about the IP address. In each client machine in the network has a unique unique IP address. Okay, so you need the unique IP address. So for why you need this unique IP address? Because it will identify the device on the network. Okay, so if let's suppose we have a computer here. This computer, how it will be identified in the network? Let's suppose we have a multiple computers. These multiple computers are connected to the switch, and this switch is okay through the switch. So if one computer want to communicate, let's suppose we have 1, 2, and 3, these 3 computers, and if they want to communicate with each other, how it will be identified and how they can communicate with the help of the IP address. Okay, so they can communicate with the help of IP address. Okay, same like how your car will be identified in ROP with number, right? They have a number plate. Let's suppose we have a car. Okay, if you will go to the ROP, so the ROP, how it will identify your car with number plate, right? There is a number plate, right? Right? Yes. So So with the help of this number plate, your car is identified or your car can be recognized. Okay. So because let's suppose now in this example, if you will see here, IP address 192.168.0.2.0, each of the four dots. So here this is 192.0. So 192.c here. So you can write here 192. Then there is a dot 192.168 dot. That's for 0.1. So these numbers are, so each number here, let's put this number and this number. So these numbers are represented in a 8 bits. See here 192, you see here 192 is represented in a binary into a 8 bits. Okay, we call the octet. So we 8 bits. Okay? So these numbers are represented to convert 192. So in a binary, so this is a binary conversion of 192. Okay, and it can be represented in a 8 bits. So 8 bit or we call the octet. 8 bit we call octet, octal number. Okay, so this is octet. Okay, we call octet or 8 bit. So what does it mean? Each of the four number can be anything between. So this number can be in between 0 to 255. Okay, so these number can be in between anything. So here it should be divided into a four groups. So you have group one. Let me take some other here. Let me take that one. So here one group, second group, three, and four groups. Okay, so this is the basic format of IPv4. Okay, IPv4 are divided into a four groups. Okay, so you already know about it. You already studied. This is just a recap. Okay? So total number of bits, if you will divide, see here. So each number is represented into 8 bits. If you see here, 8 bit, and 0 representing an 8 bit. Again, 2 representing an 8 bit, and again 0 representing an 8 bit. Okay. So total, how many bits we have? Total number of bits. How many total number of bits we have? 32 bits. See, 8 plus 8 plus 8. If see here, plus 8 plus 8 plus 8 equal to 32. Okay. So total number of bits are 32. Okay. So this is the IP address recap. Okay. Now, so again, here, if you see here, we are going to recap about IPv4 and IPv6. So IPv4 is 32-bit address, as we know. So it is good. So this is class C address, and now IPv4 is 128-bit address. Okay. So now see here, this is 128 bit address. So 1, 2, 3, 4, 5, 6, 7, 8 groups. Okay. Now it is divided into it. So each one is 16. We call hexa number. Okay, this is the hexa exit. We call the exit. So I don't want to go in detail. Just you need to understand only. So IPv4 address is 32-bit address, and IPv6 is 128-bit address. 128-bit. So we already studied these things in detail in our computer network fundamental class. So if you see classless interdomain routing, CIDR, if you see here, CIDR, so 192.0, so this is IP address. Okay? This is the IP address. Let's put 1, 2, 3, and 4. So this is your IP address. Okay, 192.0.2.0/24. Okay, this 24. What does it mean? This 24. Can anyone tell me? Yes, Shahar. Can you tell me what does it mean? This 24. What does it mean? Yes. What does it indicate? This /24. Yes, please. Anyone? Shahar, can you hear me? Shahar? Yes, please. Do you know what does it mean, this slash 24 mean?
The bits.
Yeah, number of bits. Yeah, number of bit mean in the network portion, right? Slash 24 network portion. 8, again 8 bit plus 8 bit. So these are the network bit, and this is your host portion. Host portion you have 8. So this one is your host portion. Okay. The host portion, you can do the subnetting in the host portion if you remember, right? I'm not going in detail. You already learned about it. And if not, please go through again. Okay. So this 8 bit is the host portion. You can do the subnetting in this one, in the class C. This is the class C. Okay. So this one here, you are flexible, and then we can do the subnetting portion in this 8 bits. Okay. So these are the fixed. In class C, these are fixed. Okay. These are the fixed. So this will remain fixed, but here it will identify the host. And if it is 1, mean first host. If you will go for the second host, third, fourth, so on and so far. Okay. So this 24, it will identify how many bits are fixed, mean how many bits for the network and how many bits for the host. Okay. This is called CIDR. Now this is our open system interconnection model. Okay. Open system interconnection is a logical model. If you see here, so we have how many layer we have it? 7 layer. Okay. 7 layer. Physical layer, data link layer, network layer, transport layer, session layer, presentation layer, and application layer. So application layer, it is on the top, and so me for the application to access your computer network, like your HTTP protocol, FTP protocol, DHCP, LDAP. It is, so this is your application layer protocol. Then presentation layer, ensure that the application layer can read the data and it can encrypt. Okay. So the encryption and decryption happen at the presentation layer. Session layer enable the order exchange of the data. So data orderly exchange on the session layer. So transport layer provide the protocol to support host to host communication at the transport layer. So these are the protocol TCP and the UDP are operating at transport layer. Network layer, your routing and the packet forwarding, and like your routers operate at network layer. So like the IP address, okay, so it is operating at the network layer. So data link layer transfer the data in the same LAN, local area network, okay, and bridges and the switches. So your MAC addresses operate at data link layer. Okay. And the physical layer is the transmission and reception of the raw bit stream over a physical medium. And so because how the data is transmitting on your physical medium, like on a cable, like UTP cable, like it is transmitting in zeros and ones. Okay. So it is on the physical layer. Now we will discuss about the VPC. So if you see here, your VPC enable you to provide a logical isolation section of AWS cloud where you can launch AWS resources in a virtual network. What you define it. What the VPC will do? Yes. What is a VPC? Yes. Anyone can tell me what is VPC? VPC is your virtual private cloud. Virtual okay, virtual private cloud. Okay, so this is your virtual private cloud. Okay, virtual private cloud. What it will do? It will enable you to logically divide the section of AWS cloud where you can launch AWS resources in a virtual network. Okay, so here let's suppose, see here, now this is your boundary wall. This is your VPC, virtual private cloud. Okay, this is your VPC. Inside, you can put your resources like EC2 resource, EC2 instance, you will put it inside this one. So your EC2 resource is virtually isolated, mean it provides the security. So the other, let's suppose the other user will not able to access your resources which you kept inside the VPC. Let's suppose you have another user. This is a user one. User one. So user one created this EC2 instance inside this VPC one. Another user, user two, created another EC2 instance. Okay, EC2 instance inside the VPC. Maybe it is another VPC inside this VPC. So these VPCs, they cannot access. So user one cannot access the resources of VPC2 and sorry, user one. This is user one. So this is, let's suppose, user two. User one cannot access the resources of VPC1, mean the user two, and user two cannot access the user one resources because this VPC provide a security. VPC provide a complete security, okay, of your resources. Same like, let's suppose if you are some resource, as I said, let's suppose this is the street, you are living in this street, right? This is your street. Okay, let's suppose in this street you are living in this street. So here we have a multiple houses, house one, house two, house three, different houses are there. So it means, so each house considered as a VPC. Yeah, each house inside the street you can consider as a VPC. So this is house 1, 2, 3, and 4. These 4 houses in this street, okay? This street, let's suppose in this street, you have these 4 houses. So each house is considered as a VPC. So whatever is inside the house, so it will kept secure and private for that house. So it means, so this house 2 cannot enter into house 1 and the house 1 cannot go to the house 2 resources. So because these are the private houses, so they cannot do it, okay? So last time we discussed, but in some cases, as last time we discussed, yes, how they can access their resources. If we allow them, yes, it can be accessed. So which methodology was used? VPC pairing. VPC pairing is a methodology, is a method to communicate between 2 VPCs. Okay, we discussed in our last meeting as well. So now give your control over the virtual network resources, including selection of IP address range, creation of the subnets, configuration of the routing table, and the network gateway. So first you need to configure. So how you can create your VPC? First you need to create the VPC. Then you should have the IP address range. Okay, this VPC you need to assign. Let's suppose you have the VPC. So this VPC you need to assign the IP address. Okay, IP address, the network address we can call. Okay, so this should have a IP address range. Then inside the VPC, let's suppose you have different EC2 instance. Okay, so each instance will be, this is your VPC. Okay, as a whole, this is your VPC. So then in each instance you need to create a subnet. This EC2 instance 1, in this instance 1 will be having subnet 1, and this EC2 instance will have a subnet 2. So you need to create a different subnet if you are creating a different EC2 instance. Okay, so now then, okay, here they give some little bit clarity here. Now if you see here, you have the VPC. See here, you have the VPC. This is your VPC. Okay, inside the VPC you have subnet 1, you can see here, and subnet 2. Let's suppose the VPC you assign this IP. Okay, let's suppose the VPC IP is 192.168. Let's suppose 1.0/24. Okay, let's suppose this is a network IP. assigned to the VPC. Okay. So then you need to divide this VPC into two subnets. Okay. So the subnet 1, you can go for the subnet 1. Let's suppose how we can divide into two subnets this IP. Let's suppose if you need to divide 192.168.1.0, so divide into two subnets. Okay. Divide this IP into two subnets. Okay. Let's suppose divide. How you can divide into two subnets? Into two subnet. This IP subnet. Okay. How you can divide into two subnets? This IP, this network into two subnets. Here we have /24, right? /24. If you need to divide into two subnets, so just the last, take one bit here, okay? So here make it 25, okay? So just borrow one bit here and it become, so the first IP, I am not going to teach you the IP addressing now, okay? So you need to revise by yourself. So the first subnet, subnet 1 will be, subnet 1 will be 192.168.1.0 sorry, 25, and subnet 2, if you see here, subnet 2 will be 192.168.1. Yes, anyone can tell me what will be the subnet 2? Yes, please. What will be the subnet 2? Yes. What will be the subnet 2?
128.
Anyone? 128. Very good. So your 128. Yes. So this is your subnet 2. So the first IP for this one will be 1.1, first usable IP, and the last usable IP will be 1.26. You know this one, right? 126. Right? You know this one. We already discussed. Very good. Very good, Shahan. So 1.128 if up to 255. Okay. So this will be the subnet 2. So first, so subnet 1, you can assign here 192.168.1.0/28. Sorry, 25. Okay. So this subnet you assign to this here, and the second subnet will be 192.168. Sorry, 0, sorry, 1 dot. Minute. Let me take the razor. So here 1.128, okay, 128/25, okay, /25. See here. So you divide. So here you have one. This is your VPC. Inside the VPC, you created two subnets. Okay. Now what will happen? VPC, what it will do? It will logically isolate, mean logically divide from the other VPC. Let's suppose if you have another VPC, so one VPC, see here. Now you need to understand here. If you are going to create any EC2 instance, okay, if you are going to create any EC2 instance, where it will be created? Yes, where you are going to create this EC2 instance? It will be inside the VPC by default VPC, okay? So you cannot create any EC2 instance without the VPC. Please just keep this thing in your mind. Without VPC, you cannot create any EC2 instance. EC2 instance means you cannot create any server. You cannot put any server in a cloud. Okay? EC2 instance means any server on the cloud. Okay? So it means you must have the VPC. Without VPC, you cannot put your server on the cloud, mean AWS cloud, Azure cloud, whatever the cloud it is there. Okay. So you must have the VPC. So this is called the default VPC. Once you create your account, so default VPC will be created. So dedicated, this VPC dedicated to your AWS account, this default VPC, okay, and belong to a single AWS region and can span a multiple availability zone. Inside the region, you have availability zone 1, availability zone 2, you can see here. So you have a different availability zone inside the region, okay. Then subnet, see here again, range of the IP address that divide the VPC. So your VPC, you have this one, the I1.0, this is the address assigned to this VPC, this network address. Then this one divided into two subnets, okay. So divide this one, okay. Then belong to single availability zone, okay. So your VPC belong to single availability zone, okay. Availability zone 1 and availability zone 2. So you created one subnet in availability zone 1 and availability zone 2 second subnet. And this VPC classified as a public or the private. So it means, so it is recommended to have a private address range. Even you can create with the public IP address. This is not a hard and fast rule. So the public subnet have direct access to the internet, but the private subnet do not. So if you have see, if the public and the private addresses, you know, right? So public addresses and the private addresses. So just I want to just recap the public addresses and the private addresses, okay? So if you have a public addresses are directly routable on the internet. Private addresses will retain within your local area network. It can mean private addresses are non-routable addresses. We can say in a simple term, you can say if someone will ask you what is the difference between public and the private, simply you can say public addresses are routable addresses on the internet. It means you can access your device on the internet. But if you have the private addresses, these private addresses, let's suppose your EC2 instance have 1 dot, let's suppose 5 IP address you assign to your EC2 instance. So this private addresses will not be accessible through the internet, okay? So what you need to do in this case, if you have the private addresses, okay, what you need to do in this case, there will be a routing table and there is a internet gateway. We will see in couple of minutes. So how you can access this EC2 instance? Let's suppose you have EC2 instance here, EC2 instance, one EC2 instance here, and the EC2 instance on the second subnet. How you can access through the internet? Let's suppose this is your internet. How you can access through the internet? Through the internet gateway, and here will be a routing table. Routing table. Okay. So here you have a routing table. So we will see once we will once we will complete our lab today, then you will better understand. But try to visualize this concept. Okay. So you have the availability zone, inside the availability zone. So you are creating a VPC. First, there is a VPC inside your availability zone. Then you need to create the subnets which belongs to this VPC, and then there will be a internet gateway and the routing table. Okay, now see here. When you create a VPC, you sign to a IPv4 CIDR block range of private IPv4 addresses. We have seen. So if it is /16, so how many maximum hosts can be accommodated? 65,536 hosts. Okay. If it is /28, yes, 628. It means 28 bit for the network, and how many bit for the host? Yes, this /28 means 28 bit for the network, right? So total number of bits here, how many? Total is 32, right? 32 bit address, huh? 32 bit address, right? So 28, 4 bit left, right? So if you have the 4 bit, how many hosts we can accommodate if it is /28? Yes, anyone can tell me? Yes, please. If it is /28, how many hosts we can accommodate in this case? Yes, please. Anyone?
16.
Yes, 16 addresses. See here, 2 power 4, na? 2 power 4 mean 28 bit, right? So 28, 32 minus 28. If you will see here, how many bits? 4 bit left, right? 28 bit for the network, and this whole total bits are 32. 32 minus 28, 4 bit for the host. If 4 bits for the host, 2 power 4 is 16, right? 16 minus 2, so it will be 14 host. Okay, total 14. Okay, so you know the number of hosts, 2 power minus 2 power h minus 2. You know this one, right? We already explained our computer network fundamental. Now here is the point. Now I'm telling you the point. So the largest IP4 CIDR block size you can assign inside the AWS to your VPC. So maximum block size you can give 16. Okay, it is fixed. You cannot give 14, you cannot give 13, you cannot give 10/10. Okay, so it should be in the range of 16 up to 28. So the largest IP addressing mean, so you can give 16, and the smallest one you can give 28. In between this range, 16/16 in the range, or you can give maximum, mean the smallest one /28. Okay, this is the range between. In this range, you can give any network address to your VPC. Okay, so IPv6 is also supported with a different block size limit. So IPv6 is also supported, but we will just only focus to the IPv4 here. Okay, so CIDR block of the subnet cannot be overlap. If you are using CIDR, definitely it will not overlap. Okay, so get to know. Now, reserve IP addresses. So reserve IP addresses, if you see here, the VPC with IP4 CIDR block 10.0.0.16, it means 65,536 total IP addresses. Okay, total how many? 65,000 to power 16. Okay, because this 16 for the network and 16 remaining for the host. This is for the host minus 2. So it becomes 65,536 total IP addresses. The VPC has 4 equal size subnet. Only 251 IP addresses are available for the use for each subnet. So now if you see here, let's suppose if it is /24. Okay, let's suppose now we will I try to make things simple. Okay, 192.168.1. Let's suppose 0/24. Okay, so total how many? So here 2 power 8 minus 2, right? Number of host. Okay, number of host addresses. So how many number of host addresses here? 2 power 8 minus 2, 256 minus 2, 254, right? Yes, 254 total number of hosts, right? So total number of hosts you can accommodate here with this /24 is 254, right? In a normal subnet, correct? But there is a one catch. Okay, one catch here. If you are creating your VPC, inside the VPC you have subnet 1. So in the subnet 1, you can use only these 251 addresses, not 254 addresses. See here, if it is /24, see here, if it is /24, total number of host addresses are 254, right? But they are saying maximum you can use 251. Some addresses are reserved. Yes, some addresses are reserved. So why it is reserved? Yes, why it is reserved? So the first address, let's suppose the first address 192.168.1.1, let's suppose the first IP will be, what is the first usable IP for this one? Okay, I will write it here. First usable IP 192.168.1.1, right? This is the first usable IP. Yes, first usable IP. I will write first. Okay, wait. This is our first usable IP. Okay, first usable IP. 1.1. Second usable IP is 1.2. And third usable IP is 1.3. Yes. So they are saying you cannot use 1.1, 1.2, 1.3 because this is a network address, right? This is a network address. And for this network, the first usable IP is 1.1, second usable IP is 1.2, third usable IP is 1.3. Yes, correct? But in your VPC, inside the VPC, you cannot assign this 1.1, 1.2, 1.3. First three IP you cannot assign. Maximum you can go 251. See, total we are 254 minus 3, it becomes 251. So the first IP will belongs to your router, the gateway IP. The first IP will be your gateway IP. Okay, it will assign to your gateway, to your router. Okay, and the second IP will be assigned to your DNS. It is reserved for the DNS. Okay, and 1.3 for the future use. Okay, for the future use. So it is reserved. That is why they call the reserved IP. First three IP in each subnet. In each subnet, first three IP are reserved. Okay, please keep things in your mind. In each subnet, here also, subnet 2 also again, first three IP, 1.1, 1.2, sorry, 2.1, 2.2, 2.3 are reserved for the same purpose. Okay, same here. Okay, understood? So these are reserved. And why it is reserved? The AWS they reserved for the gateway, DNS, and future use. Okay, so these IPs are reserved. Public IPv4 addresses, then there is one concept of the elastic IP address. Okay, now what is the public IPv4 address? Yes, do you know about the public IP address? Yes, please. Anyone? The difference between public and private IP addresses? Yes. Yes, please. Public addresses, I just explained a while ago. Yes, please. Anyone can tell me what is the public and the private address? Public address and the private? Yes.
The public used on internet and globally
Yeah.
unique, but the
Very
private
good.
used in local network.
Very good. Very good. So public addresses are in a simple way. Very good. So public addresses are routable addresses, mean it is accessible from the internet, public address, but the private addresses are non-routable address. Now there is a one point here, like then we have the elastic IP address. If you see here, the elastic IP address. Okay, in this elastic IP address, they said it is associated with the AWS account and can be allocated and remapped anytime, and additional cost might be. So just elastic IP address. So try to understand this elastic IP address is a concept from Amazon in your Amazon Web Services, like in AWS. So this is a static public IPv4 address. So you can allocate to your AWS account and then attach to the resource, to your EC2 instance. So what is the key point here? Unlike your normal public IP address, if you assign to your EC2 instance, so it will remain static, does not change. Okay, it will be fixed. So why you use this elastic IP address? Because let's suppose if you are hosting a website, okay, so once you reboot your EC2 instance, you will not get the new IP, right? See, public IP, if you are assigning, so you are not assigning the public IP, right? So who will give the public IP? Yes. Who give the public IP? Yes, please. So who give this public IP address? Let's suppose you have the EC2 instance. If you create the EC2 instance, who give the public IP address? You are not assigning public IP address, right? So AWS assign a random IP to your EC2 instance, right? You experience this one, no? Shall I show you, or you know this one, right? When you are creating EC2 instance, what happened? So your AWS assign a public IP to your EC2 instance, right? Through this public IP, you can access remotely to your EC2 instance, right? Correct? Understood? So this is your public IP. Okay, it will assign randomly. Who will assign? AWS, because you don't have the control. You cannot assign by yourself. Okay, it is assigned by AWS. Okay. Now, what I told you, let's suppose you have a web server. Okay, let's suppose you have a web server. Okay, and okay, before going to the web server, so if you restart the EC2 instance, next time this EC2 instance, let's suppose this time it get, let's suppose 69.1.1. Let's suppose 200. This IP it get it first. Okay, once you create EC2 instance, it get this IP. Okay, but once you restart the instance, okay, then maybe the second time, first time it get this one. Second time, maybe once you restart, it might get maybe 70.1.1. Let's suppose 56. See here, second time it gets this IP. Once you, it means if you have a web server on in this EC2 instance, what will happen? So your IP will be changed, right? Your IP will be changed. So it means your web server will not be accessible. So it should have the static IP, right? Static IP. The IP should not be changed, right? So how you can assign a static IP? The IP, even you restart your EC2 instance, so this IP should not be changed. This IP should not be changed. So through this elastic IP address. So through this elastic IP address, you can assign, so you can fix the IP address. Okay, you can fix this IP address, public IP address. So this elastic IP address can be allocated and remap anytime. It means it will be fixed, but the catch is here. The point is here. So this, if you create this elastic IP address, please be careful. It will apply the additional cost. It means it will cost you money. Additional cost will be applied for this, because this IP will be reserved. One public IP will be reserved for this instance, static. Okay, so you need to understand this concept. Okay, elastic IP address concept. Understood? Yes, please. Now, so why you use it? Because hosting a website, So your fixed IP, you required a fixed IP. So it will avoid your downtime by switching the IP between the server and so. But as I said, AWS will charge for this elastic IP if they are, even if you are not attaching, if your instance is not running, still it will charge you. Okay, so you should be careful if you are using this elastic IP. Now, elastic network interface, let me check, do we have, okay, still can we go for the practical? No, I think we don't have enough time now. And okay, so elastic network interface, okay, discard. Okay. Just we can go to the practical then, in this case. Yes, please. I will just show you. Okay, just let me go to the. You can also please log in your AWS account. Till we have 10 minutes. Within 10 minutes, we can finish one practical here. Okay, what we discussed today. Let me go to the AWS. Let me log in. Okay. Yes, please. No. Okay. You cannot reuse the old password. Oh my God. Okay, now I have login. Let me share the screen now. Stop sharing, share again. Okay, see here. Now I'm going to log in, and within 10 minutes, I will just explain you the different VPC, default VPC, and all other thing, how you can create your own VPC. So here we have this one. Okay, this is the lab you need to do by yourself, or I will just explain you step by step. Okay, let's pause here. We can go for the. Okay. Let me arrange it in proper way. So same time you can read and you can finish it. Just video. Okay. Launch the lab. Okay. Meanwhile, I'm going to read this one. Here, let's suppose you have a lab. Let me start the lab here. Start the lab. Start the lab. Okay. Now, in this lab, you will use VPC to create your own VPC and additional component to produce a customized network. So you will create a security group. You will then configure and customize the EC2 instance and run the web server. You will launch EC2 instance to run this subnet in the VPC. So Amazon Virtual Private Cloud enable you to launch the Amazon Web Services resources into the virtual network that you will define. This virtual network closely resemble a traditional network that you would operate in your own data center. With the benefit of using scalable infrastructure of AWS, you can create a VPC that span multiple availability zones. After completing this lab, you would be able to do the following: create VPC, create subnet, launch EC2 instance. Now, what they did it. Okay. Now, here, try to understand now. First, try to understand this concept here. What we are going to do now. Okay. See here. So, see here. Now we have this scenario here. Okay. This is your VPC. Okay, this is your VPC. Okay, this is your VPC. Inside the VPC, they are not. See, they have not done any subnetting, but they use 10.0.0.16. Okay, what they did it? They use this one. Okay, 10.0. So what is the IP they use? 10.0.0. Sorry, this is 0.0./16. Okay. 16. Okay, so this is the VPC. Okay, this is a network. Okay, this is your network, but inside they use public subnet. Okay, 10.0.0, sorry, 0.1.0, one subnet, and 2.0/24. Okay, so here inside they use, because here they need 254 hosts, but practically they can assign these IP 251 user they can accommodate here, and 251 user they can accommodate here, because they did the subnetting here. First subnet 10.0.1.0/24, and second is 10.0.2.0/24. Okay, so total IP addresses, because 3 IP addresses as we discussed reserved. First 3 IP reserved. Okay, how many IPs are reserved? Reserved. In this one, first 3 IP reserved. Okay, as I told you, for the internet gateway and DNS and the future views for each subnet. Okay, so total number of hosts is 251. Mean 251 EC2 instance you can easily create here. Okay, like you can assign so different IP. So 251. Okay, so 1.0 and 2.0. So this is your subnet, 2 subnet created inside your VPC. So we will follow the same. So first we create the VPC and we will assign 10.0./16. Inside we will create 2 subnet 1 and subnet 2. Okay, so these are 2 private subnets. Okay, please keep it in your mind, not a public subnet. These are the 2 private subnet, 10.0.0.1, 10.0.0. So these are the 2 private subnets. Okay, then we will create a routing table, and this routing table, then we will create one internet gateway. Then you will able to access your resources. If you kept some EC2 instance here, so you will able to access your EC2 instance. Okay, so this is the scenario here. Okay, now see now. So we'll go step by step now. First, you need to create your VPC. Okay, first you need to create your VPC. In this task, you will use VPC for more option, console to create multiple resources. Okay, internet gateway, VPC, internet gateway, public. Sorry, these are the 2 subnet 1 and subnet 2. Okay, we will name it subnet 1 and subnet 2. They name it public subnet and the private subnet, because they name this one public, but actually it's not a public. Okay, they just try to name it public and single availability zone, 2 router tables. Okay, so inside they have 2 tables. Okay, 10 and this one. Okay, and one is connected with the internet gateway default route and the NAT gateway as well. In the search box, go to the services and type VPC. Okay, then now we will go step by step here. Go to the search box. Okay, in the search box, type here what to type: VPC. Okay, so this is your VPC. Okay, then on the top right of the screen, just you can see Virginia. You see here, this is your region. Yes, and Virginia, United States, US. Okay, so this is the region. Then choose the VPC dashboard link, which is toward the top left of the console, and create VPC. See here, create VPC. Okay. Now here, VPC and more. If you see here, you have the option now. So two options. Okay. VPC, choose VPC mode. So we will see, select this one, the default one. Don't go for VPC only. VPC and more. Okay. And you need to use this name, lab_VPC. Okay. Here, name tag. What is the name tag here? Lab VPC. Okay. So we will use this name, lab VPC, or you can write it like VPC. Okay. Lab VPC. And keep the IPv4 CIDR blocks at 10.0.0.16. Okay, this is your VPC. Okay, then availability zone, choose one. Okay, so here default tendency, default availability zone. So what you need to choose? One. Okay, availability zone one. Okay, what is this availability zone? You know, US Virginia 1, 2, and 3 availability zone in this region. We have 3. Okay, in this region, see in this region, how many availability zone we have? 3. Okay, so we will select 1. Even you can go 2, 3, no problem, but we will select 1. Okay, because in each availability, in each region we have 3 availability zone. Okay, so in this case we will choose 1, and public subnet, keep the 1 setting. So here we can use public and number of private 1. Okay, so you have public IP 1 and private subnet 1. Okay, it is already 1. Then expand the customized subnet CIDR and change this one. Okay, US East 1, US East 1A. So you need to assign these 2 addresses. Okay, now. So customize subnet. So here, if you see customize subnet, CIDR block here. Okay. So in this one, here you need 10.0.1.10.0/24. This is your public, and here you can go for 10.0.2.0/24. Okay, so we have public subnet and the private. These are the 2. Then NAT gateway none. Okay, and the VPC endpoint none. Okay, VPC endpoint none. Okay, this point, and keep the DNS host name resolution enable. Host name, so this one should be checked. Okay, enable resolution should be enabled. And in the preview panel, right, confirm the setting, and you have configure and create the VPC. Okay, then see here, this is your right panel, East 1, A, and 2. See here. So now this is your. Now you have the VPC. Inside VPC, you have subnet 1 and subnet 2. Okay, so you have 2 subnet, public 1 and private 1. Then your routing table is by default it will be configured. Okay, so it will be configured. Okay, understood. Now after that you need to click on create the VPC. Now it will take some little bit time and it will be created. Now you can see it is going to be created. So the VPC resources are created. NAT gateway will take a few minutes to activate. Please wait resources, and okay, once it is completed, choose your view VPC. Okay, so what you need to do here, so view VPC. Okay, so view VPC. Okay, so here view VPC, and the wizard has provisioned a VPC with the public subnet and the private subnet on one availability zone. With the routing table for each subnet, it can be created on the internet gateway. See here. This is the map here, if you see here. See, this is subnet and routing table. So this is your VPC roadmap. Okay, now it is created. So in the internet gateway, VPC resources that allow the communication between EC2 instance and VPC and the internet. Okay, like your internet gateway as of now. So what we need to do? So the lab subnet one public one use east public east one. So now you have 1.0. This is your public, which means that it contains the IP address starting with 10.0.1. This is the X mean. These are the host addresses. The fact the routing table associated with the public subnet route 0.0. So mean the default network traffic to the internet gateway. So which make it public subnet. Okay, so here we will add this 0.0 network. Okay, this one the default. So NAT gateway in the VPC resource used to provide internet connectivity to the EC2 instance running on the private subnet VPC without EC2 instance needing this. Okay, now second one. So lab subnet private, and which means it contains the IP address starting with 2 dot and number of hosts. Okay, so this is launch the web server instance. In this task, you will launch Amazon EC2 instance into a new VPC. Okay, so you need to configure the instance to act as a web server. So in the search box, okay, we will go to the search box here, and what we will do, we configure now EC2 instance. Okay, here EC2 instance. Okay, launch EC2. Okay, then okay, wait. Okay, launch EC2 instance here. Now we need to create the EC2 instance. So name it web server 1. Okay, web server 1. Okay, and create tag and key pair and everything, and then Amazon Linux AMI. Okay, choose the instance type, key pair, name menu. Okay, we will do this one here now. So here, as of now, see, so you need to create this plus T3 micro key pair. I will use here. Okay, no problem. And then, or I can use a walkie key, no problem. Whatever you want to use, no issue. Then here the subnet. See here. So now this is your VPC. Now you need to click on edit, and you can use, this is the VPC you created, right? So now you need to add your EC2 instance in this VPC. See, this is the default one, but this is your customized, right? Understood? Yes, please. Jahar, you can see here, right? The one here, it is default, but now we need to choose the customize, which we created in our previous step here, right? So see here, the IP is 10.0.0.16. This is a subnet IP, right? So we are selecting this one. Okay, now we will go step by step. We are selecting this one. So now we select this, then subnet lab public. Okay, and then auto assign IP address. Okay, then create a new security group. We will see here. Okay, so after that you have the subnet. See here you have two subnets, subnet 1 east, and here auto assign IP enable, auto assign public IP, we need to make it enable. Okay, and after that you need to web security configuration. Here you need to configure the security group. It's already there, security launch wizard. Okay, SSH, HTTP, HTTPS. Okay, so we need to assign here. Okay, no, so what we need to do, inbound rule and outbound rule here, we need to add the security group rule here. Okay, now add the security group rule. Okay, so SSH also, and here No, I think it's done. Add the group. Okay, HTTP and HTTPS. Okay, from anywhere. Then add one more group. HTTPS also. We can go for the HTTPS and from anywhere. Okay, so they said okay. So we add HTTP. We allow HTTP and HTTPS traffic. You know this one, right? In the inbound rule. So we allow this traffic and configure the following setting: type HTTP and source anywhere IP. Okay, we configure both HTTP and HTTPS. So in the configuration, default setting, and here to go. So we need to run this script. Okay, so here add security group rule. Let me just remove this, make it big. Okay, advanced. In advanced, keep it as it is, and here we will use this one. Okay, just let me copy and paste it here. This is the web server. You know this one. This is the bash scripting. We are going to update our HTTPD, and then we need to enable this HTTPD and this one. You know this code, right? Okay, so now, hello, this is our first custom cloud, custom VPC in cloud world. Okay, custom VPC. Okay, so now you need to launch the instance, and here to go. Just you have launched your instance. Okay, so it means you have created your own VPC. Okay, in the network. Okay, so this is your EC2 instance. Now we can go and check here. Okay, now connect. You need to connect it, and here to go, connect the public IP address. This is the user. Okay, okay. First, you need to download the key, the walkie key. Okay, you know how to download the walkie key. I think now the time is up now, so you can download the walkie key. Okay, where is the key? Where is the key? Let me go to the key. Where is the key? We can download the walkie key. Okay. 1 minute. Walkie key. Terminal. Run AWS. Okay, AWS cloud command. Okay. SSH putty, and this is the IP browse. Okay, so you need to download. Okay, download lab user. Okay, POEM. Okay, this is the detail. README. AWS detail. This one. Okay, here is a download. Okay, so if you need to download .po, I'm going to lab user.pem and lab user this one. Okay, so I have downloaded both. So let me just log in here through this one, where it is. To go to the notepad. README from a Windows. Okay, so I will use this one, chain mode, CMD. Let me go for the CMD, PowerShell, SSH-I. Okay, the file name. So what is the file name here? Let me go to the file name is here. This is the file name. Okay, file name labuser.pem. Okay, then EC2 instance, EC2 at the rate public IP. Okay, what is the public IP here? So this is your public IP. Okay, let me connect. Okay, now you can see here. Now we are going to access this. Oh, we need to go to the download first. Wait. No such. Okay, Control Z. Window PowerShell first. Where is the download? Download. Okay, this is the download. Okay, let me go to the CMD. Okay, now I'm in the download now. Here, I need to access now. Okay, so how you can access? As I said, so here to go instance. Okay, now let me copy this one. SSH minus I. Okay, one. Where is the? Okay, so SSH minus I. Where it is? SSH minus I. File name. Oh my God, where is the file name? So this is your file name. File name. POEM, rename, copy, and then public IP. Sorry, at the rate, see here, at the rate. PEM, EC2 user, EC2 user, EC2 user, EC2 user at the rate, then the public IP. Okay. Now here, no such file. Why we don't have the lab? Okay, SSH minus. Okay, so what you can do, you can access through the SSH through the window PowerShell lab user one.pem EC2 user 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 connect. Okay, connect to the SSH port 22 connection timeout. Okay, the connection timeout. Why the connection timeout? User 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 at the rate public IP. Okay, 442.1.2.44.74. Yeah. Okay. So then type yes. Okay. See here. Now you can connect it here, but see your this is your EC2 instance. Okay. Now you can connect through the SSH. Okay. Or through the PowerShell, it is this EC2 instance. Okay. How many instances you have? You can see here. This is the web server one. Okay. Now the difference between you can see here. So here is a walkie key, and here you can see here. So this is your EC2 instance with. So if you want to see the VPC, these two. Just let me go to the security group plastic IP. Okay. Now you have created your EC2 instance in your subnet. Okay. So this one. So it's already there. So you can access by using SSH client. Okay, software. Now in this one, you need to go to the SSH. Okay, and you need to connect. Okay, so you need to connect it. So how you can connect? Even though this is your if just you want to connect, or just you want to see where is this one launch EC2 instance here. See, okay, where it is. So now you understood how you created your EC2 instance. In next class, okay, I will keep it running, and I think after the E, so you can, okay, see here. 1 minute. Now what we did it as of now, just 1 minute. Okay, now see here. So we run this one, the script will run the root user permission and guest OS for the instance. It will run automatically when the instance launch. At the bottom of the summary panel on the right side of the screen, choose the launch instance. You will see the successful email. It means you have successfully logged in. So no need to this one, what we call it. So you can check your this EC2 instance here, but why we will not able to access it? Yes, there is a point, because the internet gateway is the issue. So we need to configure the internet gateway, but we finish our lab, because in this lab we don't need to access up to this point, just we need to do. Okay, so we finish our lab up to this one. Okay, so we have configured our lab, but why we are not able to access it even through the HTTP? Because we need to configure the internet gateway. Okay, so what we need to do, then we need to configure the internet gateway. Okay, so we did not configure the internet gateway. Okay, internet gateway. So in this one, we need to configure internet gateway. Without internet, as I said, so first routing table. So you have this routing table, subnet 1, subnet 2. See here, you have two subnets. Okay, private and the public. Okay, so these are the two subnets you have it. Okay, this is your table. Okay, so this one we will learn in our next class. Okay, so this is the private east one, and this is your public. Okay, so these are the tables. Okay, you have created. So these are your table. So routing table. So you can name it my routing table. Okay, my routing table. So this is your task. So VPC. So this is your VPC. Okay, name tag RT, create the routing table. So by this way you need to create. So your routing table is configured now. Okay, then what you need to do, you need to assign this routing table to your internet gateway. Now you need a internet gateway. So this is your internet gateway. Okay, so you need to attach this internet gateway. Okay, create internet gateway, and internet gateway, my internet gateway. Okay, so you need to do by yourself. Okay, so create this internet gateway and done, and then you need to attach this internet gateway, attach to the VPC. So which VPC? Here you need to select, create the VPC. We already created the VPC. Okay, so then you need to attach this VPC. Okay, by this way you will able to access your server from the internet, but it is part of this lab. So your lab was only to create the server. Okay, so to create the server, okay, in the VPC. How to access it? For accessing, you need to create the internet. You have done your lab. Whatever the lab requirement you have done. Now I will upload another lab which you need to complete before the next class, maybe on 24th. Yeah, so 24, 25 you need to complete and upload. Okay, so that's all from my side. Thank you very much. And just 1 minute. Where to go? Where is the... Oh, this is not the one. Directory. Where is the directory? Okay. 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 Let me take the attendance. If anyone who came late, no, all are the same. Mahara Suleiman. Yes. Okay. Please, just the last one attendance. Let me take the attendance now. Stop. Stop recording.